Section 1. The fundamental trio: work, energy, and power. Work, energy, and power are interconnected concepts that govern the physical world. They are fundamental to understanding how things move, change, and interact. These principles are essential for comprehending everything from the smallest atom to the largest galaxy. Work is done when a force causes an object to move a certain distance. It's the transfer of energy from one object to another. Energy is the capacity to do work. It exists in various forms, including mechanical, thermal, chemical, and nuclear. Power is the rate at which work is done or energy is transferred. It measures how quickly energy is used or generated. Understanding these three concepts allows us to explain and predict a wide range of phenomena, from the operation of machines to the behavior of celestial bodies. In essence, they provide a fundamental framework for understanding the physical world around us. Section 2. Delving into the world of energy. Energy is the driving force of the universe. It manifests itself in many forms, each with unique characteristics and applications. From the kinetic energy of a moving car to the potential energy stored in a stretched rubber band, energy is everywhere. Mechanical energy, the energy associated with motion and position, is crucial for our daily lives. It powers our vehicles, enables us to lift objects, and drives machinery. Solar energy, harnessed from the sun's radiation, is a renewable and sustainable source of power. It can be used for electricity generation, heating, and various other applications. Other forms of energy include thermal, heat; chemical, stored in bonds; nuclear, from the atom's nucleus; and electromagnetic, light and radiation. Each type plays a vital role in natural processes and technological advancements. Understanding these various forms of energy is essential for comprehending the world around us. Section 3. Mechanical energy. The energy of motion. Mechanical energy is the energy possessed by an object due to its motion or position. It has two main forms: kinetic energy and potential energy. Kinetic energy is the energy of motion. Any moving object possesses kinetic energy. The faster an object moves, the greater its kinetic energy. Potential energy is stored energy due to an object's position or configuration. A book held above the ground has gravitational potential energy. A compressed spring has elastic potential energy. These stored energies can be converted into kinetic energy. Imagine dropping the book or releasing the spring. Mechanical energy is essential for various applications. These include transportation, manufacturing, and countless everyday activities. Understanding mechanical energy allows us to design efficient machines, predict the behavior of objects in motion, and harness the power of movement for various purposes. Section 4. Solar energy. Harnessing the power of the sun. Solar energy is radiant light and heat from the sun. We harness it using a range of ever-evolving technologies. These include solar heating, photovoltaic cells, solar thermal energy, solar architecture, and artificial photosynthesis. The sun is a powerful energy source. Solar technologies convert sunlight into usable forms of energy. These are primarily electricity and heat. Photovoltaic cells directly convert sunlight into electricity. Solar thermal collectors absorb the sun's heat. This heat can be used for various purposes. These include heating water or air, generating electricity, or driving industrial processes. Solar energy is a clean, renewable, and sustainable energy source. It holds immense potential for mitigating climate change and reducing our reliance on fossil fuels. As technology advances, solar energy is becoming increasingly affordable and efficient, paving the way for a brighter and more sustainable future. Section 5. Energy transformations from one form to another. Energy can be transformed from one form to another. This transformation is a fundamental principle that governs countless processes in nature and technology. For instance, a car engine converts chemical energy stored in fuel into mechanical energy, enabling the car to move. A solar panel transforms light energy into electrical energy, powering homes and businesses. A hydroelectric dam converts the potential energy of water stored at a height into kinetic energy as the water flows downstream, driving turbines to generate electricity. These examples highlight the versatility of energy. It can change its form while its total amount remains constant. Understanding energy transformation is crucial for developing new technologies, optimizing existing systems, and comprehending the intricate workings of the natural world. It underscores the interconnectedness of different forms of energy and their ability to convert into one another to drive various processes. Section 6. The conservation of energy, a universal principle. The law of conservation of energy is a fundamental principle in physics. It states that energy cannot be created or destroyed, it can only be transformed from one form to another. The total amount of energy in an isolated system remains constant. This principle has profound implications. It means that every time energy is used, it doesn't disappear. It merely changes its form. For example, when a ball is thrown into the air, its kinetic energy is converted into potential energy as it rises. As the ball falls back down, the potential energy is converted back into kinetic energy. Throughout this process, the total amount of energy remains the same. The law of conservation of energy is a cornerstone of our understanding of the physical world. It governs the behavior of everything from subatomic particles to galaxies, ensuring that energy is never lost, but merely transformed as it drives the processes of the universe. Section 7. Everyday applications, work, energy, and power in action. The concepts of work, energy, and power are not just abstract scientific theories, they are deeply intertwined with our daily lives, manifesting in countless ways that we often take for granted. From the moment we wake up to the time we go to sleep, these principles are at play, shaping our experiences and enabling us to perform various tasks. Consider the simple act of walking. Our muscles do work, converting chemical energy stored in our bodies into mechanical energy to propel us forward. Climbing stairs requires more power as we work against gravity to elevate our bodies. Driving a car involves the transformation of chemical energy from fuel into mechanical energy, enabling us to travel long distances. Even cooking a meal involves the transfer of thermal energy from a stove to our food, transforming its chemical composition and making it edible. These everyday examples underscore the pervasive influence of work, energy, and power in our lives. They're not merely scientific concepts, but fundamental principles that govern our actions, experiences, and interactions with the world around us. Section 8. Renewable versus non-renewable energy sustainability for the future. The distinction between renewable and non-renewable energy sources is crucial for understanding the sustainability of our energy consumption. Renewable energy sources such as solar, wind, hydro, and geothermal are naturally replenished over time. They offer a sustainable path for meeting our energy needs without depleting finite resources. Non-renewable energy sources, primarily fossil fuels like coal, oil, and natural gas, are finite resources that take millions of years to form. Their extraction and combustion release harmful pollutants into the atmosphere, contributing to climate change and other environmental problems. Transitioning to renewable energy sources is essential for mitigating these issues and ensuring a sustainable future. Embracing renewable energy technologies, investing in energy efficiency, and adopting sustainable practices are crucial steps towards reducing our reliance on fossil fuels and creating a cleaner, healthier planet for generations to come. The choices we make today will determine the energy landscape of tomorrow and the well-being of our planet. Section 9. The importance of understanding energy. Understanding energy is not just about knowing scientific definitions. It's about comprehending a fundamental force that shapes our world, our lives, and our future. Energy literacy empowers us to make informed decisions about our energy consumption, technological advancements, and environmental sustainability. By understanding the principles of work, energy, and power, we can develop innovative solutions to global challenges, such as climate change and resource scarcity. We can design more efficient machines, harness renewable energy sources effectively, and create a more sustainable energy future. Energy literacy is not just a scientific pursuit. It's a crucial step towards a brighter and more sustainable future for humanity. As we navigate the complexities of the 21st century, a deep understanding of energy will be paramount. It will enable us to make wise choices, develop innovative solutions, and ensure a sustainable future for generations to come. It's an investment in our collective well-being and the health of our planet. Section 10. Conclusion: Energy literacy for a sustainable future. In conclusion, the concepts of work, energy, and power are fundamental to understanding the physical world and our place within it. From the smallest atom to the largest galaxy, these principles govern the interactions and transformations that shape our universe. Energy, in its various forms, is the driving force of nature and the foundation of our technological advancements. As we strive for a sustainable future, understanding energy is more crucial than ever. By embracing renewable energy sources, promoting energy efficiency, and making informed choices about our energy consumption, we can create a world where energy is used responsibly, resources are conserved, and the well-being of our planet is prioritized. Let us embark on a journey of energy literacy, empowering ourselves and future generations to harness the power of energy for a brighter and more sustainable future. It's a journey of discovery, innovation, and responsibility, one that will shape the course of human civilization for millennia to come.